Hello, class. Welcome back to Chapter 12. Today we're going to be learning about the fundamental counting principle, permutations, and combinations. Let's start with the fundamental counting principle. This thing has actually two different parts to it. The first part can be said rather simply, OR means addition. If you are dealing with a problem that has the word OR in it, or if the problem is implied to have an OR, you're going to add the possibilities. Let me do a few examples to see if this makes more sense. At a restaurant, there are 3 beef dishes, 4 seafood dishes, and 2 chicken dishes. How many options do you have for dinner? Well, you could add those 3 together because you would not get them together. It's either beef or seafood or chicken. So 3 plus 4 plus 2 ends up giving us 9. So you have 9 total options for dinner. Here's another one. During first block next year, you can take a math class, an English class, or one of 3 electives. How many options do you have for first block? Well, again, that's 1 plus 3 is 5. And there you go. The second part of the fundamental counting principle doesn't deal with the word or, instead it deals with the word and. And means multiply. Again, let me do a few examples. An outfit consists of shoes, pants, and shirt. If you have 3 pair of shoes, 5 pair of pants, and 10 different shirts, how many outfits could you make? Well, all you have to do is multiply those 3 numbers together. 3 times 5 times 10 ends up being 150, and that would be the total number of outfits, assuming everything matches each other. At a restaurant, you can order an appetizer, an entree, or a dessert. 3 appetizers, 4 entrees, 2 desserts. How many meals could you make? Well, the answer is 24. You would multiply the 3 things that you're doing, the 3 appetizers, the 4 entrees, and the 2 desserts. Why don't you guys try this one out? A password consists of 3 letters, followed by 4 numbers. How many passwords are there that fit this criteria? The answer is that big old number right there. You would get this by multiplying 26 times 26 times 26, because there are 26 letters in the English alphabet. And then you'd also multiply 10 times 10 times 10 times 10, each of those representing a different digit. Again, there are 10 possibilities. And you'd end up with that giant number as a result. Let's try an even tougher one. You have 3 choices of restaurants to eat a meal. You're going to have an appetizer, entree, and dessert. Restaurant A has 2 appetizers, 3 entrees, and 1 dessert. Restaurant B has 3 appetizers, 4 entrees, and 5 desserts. And Restaurant C has 1 appetizer, 2 entrees, and 4 desserts. Considering all 3 restaurants, how many options do you have for your meal? Okay, so this one's a little bit more involved. So let's kind of go through this one step at a time. The first thing that you have to realize is you have 3 options of restaurants. You could go to A or B or C. Notice there, I said the word or, and also notice I have addition there. That's because or means addition. Next, I consider each restaurant independently. Well, the first restaurant, I have a 2, 3, 1, multiply those together. The second restaurant, 3, 4, 5, and the last restaurant, 1, 2, 4. I multiply those together and then add their results, and you should come out with 74 possible meals. Let's keep going. This is something that maybe it's new for you, maybe it's not. It's this thing called a factorial. Um, if you ever see 5 exclamation point, that's not you shouting the word 5. And if you do that, you're not funny or clever. It's been done. Instead, what it means is it means that you're taking the number that's there and multiplying it and every integer lower than it down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. If it was, say, 10 factorial, it'd be 10 times 9 times 8 times 7 times 6 times blah, 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 blah. And if it was, say, like 100 factorial, it would be 100 times 99 times 98, blah, 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 all the way down to 1. Next thing we're going to talk about is permutations and combinations. Put simply, is you selecting a certain number out of a bigger group, or choosing R things out of a pool of N options. The major difference is that permutations, order matters. In combinations, orders do not matter. We're going to do a few examples, hopefully it'll help clear it up. Before then, let me show you these formulas. You'll never have to do these. I don't want you to get overwhelmed by all this gobbledygook, but I want you to notice that combinations and permutations, you only need two numbers, N and R. N being the total numbers that we have options of, and R being the number we're picking out of that bigger number. Said a little bit differently, R is always going to be smaller than N, or at least the same size, although that's rare. Let's do some examples. Oh, also, if you just look on page 300, you'll tell you how to do it on your calculator. Page 300 is the TI tips. I think it's on the bottom. Just read that chunk right there, and it'll tell you exactly what you have to do to make it successful. All right, problem 1. Is this a permutation or a combination? Out of a class of 12, you pick 4 students to be on a council. Give it your best shot. Turns out it's a combination, and let me explain why. The reason why it's a combination is because I don't particularly care what order I select people. It's not like there's different roles. It's not like the first person gets special privileges. It's just 4 people to be on a council. So the order that I choose them doesn't really matter. Let's try another one. Out of a class of 12, you pick 4 students. 1 for each of 4 roles: president, vice president, secretary, and treasurer. Is this a combination or permutation? This is a permutation. The reason why it's permutation is because having Josh as president is very different than having Destiny as president. One of them is chaos and terror. The other one is benevolent and wonderful. I'll let you guys decide which one's which. But the point is that because there's different roles, the order absolutely matters. Here's another one. Is this a permutation or a combination? 45 people wish to apply to a company with 3 computer programming positions open. How many ways can they fill those jobs? Again, I don't care about the actual answer. Is it a permutation or is it a combination? This would be a combination because it doesn't matter the order in which I fill them. It's not like it's like a lead program designer and a code monkey. Like, it doesn't really matter. It's just 3 jobs that I'm trying to fill. The order is mostly irrelevant. Here's the last one, and this one you are going to need your calculator for. I want you guys to try this one out. You are setting the combination for a 3-digit lock. The only numbers you will be considered using are 1, 2, 3, 4, 5, 6, and 7. 0, 8, and 9 are inappropriate, and you should never use them. You don't particularly care about the order of the 3 numbers you choose. How many different passwords could you make? Take a second, figure it out. Oh, I should mention there's no repeats either. No repeats. How many different ways could you do this? Well, in this case, you're going to do 7 combination 3, which should get you 35. The reason this is a combination is because the order doesn't matter. I literally say in the problem, I don't particularly care about the order. I have 7 options, numbers 1 through 7, and I'm choosing 3 of them for my 3-number password. Despite how woefully insecure it is, that's how that problem would work. Now, for your homework, I have upped the stakes. It is no longer 10, it is now 11 problems. I think you're up to the challenge. I truly believe in you, and I hope you find success in it. We'll talk to you guys later. Take care.